Hello everyone, myself Surekha Muthal. I am working as assistant professor in Department of Chemistry from Srimati Vimlaben Khimji Tejukaya Arts, Science and Commerce College, Deolali Camp, Nasik. Today my topic is organic reactions. In that multi-component reactions, there are two reactions in today's session we will see. First one is Ugi reaction and second reaction is Manich reaction. There are some learning objectives in the today's session is to understand the concept of the multi-component reactions which are used in the organic synthesis. Now second, to recognize the importance of the multi-component reactions in the various organic synthesis. Student also learns about to understand the mechanism involved in the multi-component reactions and also to evaluate reactions conditions which are used under the multi-component reactions in the organic synthesis. Now, what is multi-component reactions? First, we will see the definition. Definition is a multi-component reaction is a chemical reaction where three or more reactant which are combined in a single vessel to form a new product, and this is the definition of multi-component reactions, means three or more reactant which are reacted together to form a product. Multi-component reactions are also known as multi-component assembly processes, and in these multi-component reactions the number of steps is reduced and process waste is also reduced during the reactions. Now here some multi-component reactions. First one is Ugi reaction, second one is Strecker reaction, third one is Gewal reaction, fourth one is Assigner reaction, fifth one is Manich reaction, sixth one is Biginelli reaction, seventh is Hunst reaction and last one is Passerni reaction. These all are the multi-component reaction. In that 3-component reaction, 4-component reaction and also 5-component reaction to get a product. Now our first reaction is Ugi reaction. So the definition of Ugi reaction is the Ugi reaction is a multi-component reaction in organic chemistry which are involving a ketone or aldehyde, an amine, an isocyanide and a carboxylic acid to form a bis amide, means the combination of aldehyde or ketone, amine and isoamide in presence of carboxylic acid to get a product. It is the most studied and used multi-component reaction in the various organic synthesis, and this reaction was reported first by the Professor Ivar Carl Ugi in the year of 1959. Here are some characteristics of the Ugi reaction. In that, first one is it is the exothermic reaction. Second application is it is usually completes in a minutes after the addition of isocyanide. Third, this is an uncatalyzed reaction. Polar aprotic solvents like DMF it is work as well. However, methanol and ethanol have also been used. It has a high atom economy as only a water molecule is lost, and for that it giving a high chemical yield of the product. Student, this is the general reaction of Ugi reaction. In that, see the first reactant is carboxylic acid reacted with amine, also reacted with ketone or aldehyde and isocyanide, means this is the 4-component reaction to yield a bis amide as a product. Here we will see the reaction of the mechanism. In that there are 5 steps involved in the reaction mechanism. First is the imine formation with amine versus ketone or aldehyde. Now second step is the proton exchange, means the formation of the iminian ion. Third step is the nucleophilic addition of isocyanide. Fourth step is the nucleophilic addition of carboxylic acid anion, and the last step in the Ugi reaction is the Mum's rearrangement. These 5 steps combine together to form bis amide as a product. Here the step mechanism of the Ugi reaction, in that step number 1 is the imine formation. See, the reaction begins with the condensation of an aldehyde or a ketone with an amine, resulting in the formation of an imine. Means see, this reaction amine when reacted with ketone to forms imine as a product. In second step, that is the protonation, the imine is then protonated by the carboxylic acid, leading to the formation of iminium ion. Means the conversion of imine to iminium ion takes place in the second step. Now the third step is isocyanide addition. See, the iminium ion is attacked by the isocyanide, forming a nitrilium ion. See, in the mechanism, the nucleophilic addition of isocyanide takes place in this step. Now in the step 4, the carboxylic acid addition, the nitrilium ion is then attacked by the carboxylic acid anion, leading to the formation of an acylated isoamide intermediate. Means the nucleophilic addition of carboxylic acid anion takes place in this reaction. In the step 5, the Mum's rearrangement. The final step in the Ugi reaction is the Mum's reagent, where the acyl group is transferred from oxygen to the nitrogen, resulting in the formation of the alpha amino acid or a bis amide as a product. See the reaction mechanism. Now here the example which are related to the Ugi reaction, means the aldehyde when reacted with an amine to yield imine, and also imine is converted to the iminium ion. Now this iminium ion further nucleophilic addition of an isocyanide to get the intermediate, and this intermediate is then reacted with the nucleophilic addition of an carboxylic acid anion, which further steps followed to get a bis amide or alpha amino amide as a major product. Now here some general application in Ugi reaction. Now the first application is it is used to develop the chemical libraries, means the development of chemical libraries, the Ugi reaction is most useful. Now the second application is it is used to synthesize a different number of components in the one reactions, means the synthesis of different component takes place in one reaction. It is the important applications in the Ugi reaction. Now the third application is the Krigzivin, means brand name for Indinavir, can be prepared by using the Ugi reaction, and this is used to treat the HIV or the AIDS. Now the fourth application is the many types of kind type anesthetics are synthesized using the reaction. For example, lidocaine and bupivacaines, means various pharmaceutical use is applicable in the Ugi reaction. Now the second reaction in today's session is the Manich reaction. So what is Manich reaction? The Manich reaction is an organic reaction that combines a carbonyl compound, an amine and formaldehyde to produce a beta amino carbonyl compound as a product. It is also known as amine methylation reactions or the amino methylation reaction. This managed reaction is invented first in 1912 by the German chemist Karl Manich. This is the most useful multi-component reaction in the organic synthesis. Now, here the general reaction. See, in general reaction, the primary or secondary amine when reacted with non-enolizable carbonyl compound in presence of enolizable carbonyl compounds which containing active methylene groups to produces beta amino carbonyl compound as a product. Now, the reaction mechanism. The Manich reaction is containing 3 steps. In that, step number 1 is the iminium ion formation. In second step, the enolization of the carbonyl compound. Third step is the nucleophilic attack and Manich base formation, which gives the final product. Now, in the next step, we will see the step-by-step mechanism of the general reaction. In the step 1, the formaldehyde when reacts with an amine, and amine is primary or a secondary, to form an iminium ion, which is also called as a skip base. It involves a nucleophilic attack of the amine on the carbonyl carbon of the formaldehyde, followed by the loss of water molecule to give the iminium ion. See, the reaction means nucleophilic addition of the amine or the ammonia takes place in the carbonyl compound, followed by the protonation. In step 2, enolization of the carbonyl compound. The carbonyl compound, for example, ketone which containing an acidic proton which undergoes the tautomerization to its enol form, and this enolization involves the abstraction of a proton from the alpha carbon by a base. Means in the abstraction of the proton is taking on the alpha proton to forms carbanion, and this carbanion undergoes in conjugation will get the formation of enol. Now, in step 3, the nucleophilic attack and the Manich base formation, means the product formation will be takes place in this step. The enol from the carbonyl compound act as a nucleophile and attack the iminium ion, and this leads to the formation of a beta amino carbonyl compound, and which is also known as a Manich base. See, the lone pair of the OH group is on conjugation, and this double bond will be attacked on this iminium ion to stabilize the nitrogen, and after that the deprotonation to get the Manich base or a final product. This is the one of the most important reaction which are used in the organic synthesis. Here some features of the Manich reaction. As a solvent and alcohol, oftenly ethanol, as well as water or acetic acid can be used. Means solvent is alcohol is used. The second feature is the reaction condition vary with the substrate, means the substrate containing the reaction condition is vary. Third feature is the Manich base formed in the reaction often crystallize from the reaction mixture or can be isolated by extraction with aqueous hydrochloric acid. Fourth feature is with an unsymmetric ketone as CH acidic substrate, two regioselective product can be formed. The fifth feature of the managed reaction is a regioselective reaction may in such cases be achieved by employing a performed iminium salt instead of formaldehyde and ammonia. Here the general application which are used in the organic synthesis means this reaction is used to synthesize various organic compounds, in that the alkaloids, peptides, nucleotides and antibiotics, polymers, agrochemicals, means various natural products can be synthesized by using the managed reaction. The second application is the managed reaction is used to synthesis of various pharmaceutical drugs including fluoxetine, antidepressant, anti-inflammatory drugs. Third application is the managed bases with their amino alkyl chains are important pharmacophores or pharmacological leads for synthesizing drugs with significant medicine value. The fourth application is the other application includes soap and detergent, synthesis of polyetheramines, synthesis of azacyclophenes and synthesis of alpha beta unsaturated ketone. Now here the two examples, in that it is for your assignment. In first example, this reaction is an example of the managed reaction, and the second is the example of the Ugi reaction. In this example, R group is nothing but your benzene, cyclic ring, tertiary butyl ring or alkyl group. Now in next lecture, student, we will see the another multi-component reaction. In that we will see the Biginelli reaction or a Passerni reaction. Thank you.